Hello and welcome to this video about permutation matrices. These matrices behave like a permutation when multiplied on the right by a column vector. It rearranges the elements in this vector as though it was being acted upon by a permutation. So here we have a permutation matrix. There are zeros everywhere and some ones mixed in. There is only one 1 for each column and only one 1 for each row. It contains only ones and zeros as elements. Now if we multiply it by this column vector, which represents the identity permutation, which is a column of natural numbers in numerical order, it acts to jumble this column as though it were acted upon by a permutation. So now to write some code to tell the user whether or not a given matrix is a permutation matrix. We'll firstly declare the function with all of its internal variables. We'll set this return variable to be true until we can find some occasion for it to be false. This matrix must be a square matrix because it must be able to be multiplied by other permutation matrices of the same size on both the right and left side. If this matrix is a permutation matrix, then we'd like to store what its permutation is in this array variable. We'll set the amount of elements in it to be equal to the number of rows or columns of this matrix. We'll then loop through every row of this matrix so as to check every row to see if there is only one 1 in it, and it having all of the other elements being equal to 0. We'll count all of the ones and zeros in each row using these variables, and we'll set them to 0 because we are using them as counting variables. We'll make another loop to look at every element in each row. We'll get the value of each entry here. We'll count up the number of zeros here. We'll count up the number of ones here. And if it turns out to be a permutation, then we'll store it in this array variable here. If there's an element that isn't equal to 0 or 1, like if it's a 2 or 3, then we'll set the return variable equal to false and exit the loop early. We can also exit the loop early if more than one 1 have been found. It makes sense to do this because it makes the function run faster. If the number of zeros and ones aren't correct, then this number will return false. And if the return variable is false, we can exit now to save us from going through the rest of the function. Now we'll check to see if this really is a permutation. We'll do this by counting up how many times each 1 occurred in each column. We'll do it differently here by checking the permutation array variable that we've just calculated. We'll use an array called occurrence, which counts up how many times each number occurred in the permutation variable that we calculated, because we're counting the number of times each number occurs. Then we'll set all of the elements of the occurrence array to 0. I did this in my video on permutation data structures. We'll count up the occurrence of each number in the permutation here. And now we'll check that each number has been found exactly once. If even one number isn't 1, like if it's 0, 2 or 3 or something else, then it isn't a permutation and we'll return false. And so we'll return the answer here whether this matrix is a permutation matrix or not. Now to make a function that constructs a permutation matrix from a permutation variable called permp. We'll declare this function with all of its internal variables here. We'll make the size of the matrix equal to the size of the permutation. We'll fill the matrix with zeros to begin with. Then we'll make a loop to go through every row so as to insert a 1 at the right position in each row. We'll get the column position for each 1 from the permutation variable here. We're adding and subtracting 1s here because the arrays begin at different locations. Then we'll load the value of 1 into this row in the matrix. Now to construct a function to create a random permutation and put it into the permutation variable permp. Now I'll fill this array with ordered elements, being the identity permutation. I've used I+1 as the loop variable, because the first element starts at entry 1, not at 0. I've also set the next two entries for error checking purposes. to see whether an entry that's too large is going to be jumbled with the other entries in the permutation. So here is where this list is jumbled up to create a random permutation. I've already uploaded another video on how to jumble up a list of ordered numbers. And so finally I'll set the number of entries in the permutation here. And we can join these two functions into this one function that creates a random permutation matrix with rows and columns equal to n. Now we'll write functions that can create two different types of almost permutation matrices that are random. The first sort creates a matrix from an array that's almost a permutation, but that has one number occurring twice, and the other sort has a random non-1-0 number inserted into it. So now to make a function that constructs a matrix that's only just a non-permutation matrix, that has one number in the list occur twice, we'll make up the random permutation like we've done before. Then we'll insert a wrong number into this permutation. We'll get the wrong number that occurs twice using this random number function. And we'll find a location to insert it into using this random number function. And we'll insert it into a location that's different to where it is already by incrementing its position until it doesn't have this value at this position. Then we'll insert it into this permutation here. Then we'll make up this matrix using the non-permutation that's got a number in it twice. And we'll use this function to create a permutation matrix with an extra non-zero 1 number in a random location. We'll set this number equal to 2. This should be read as not being a permutation matrix. And here are another two types of matrices that are only just non-permutation matrices that I'll use to test the isPermutation matrix function. One of them constructs a permutation matrix with a row of zeros. This also doubles up as producing a column of zeros, and the other one produces a permutation matrix with two ones in the same row. So now to create a function that constructs a random permutation matrix with a zero row, we'll write out the code that we used to create a random permutation matrix. Then we'll insert a row of zeros at row R. We'll put an extra condition inside the loop that won't load a 1 into a row if it's the row that we want to have as a row of only zeros. Now to make a function that constructs a permutation matrix with an extra 1 in the row, we'll write up all of the code that we used to construct the random permutation matrix. We'll select the random row and column into the matrix to load a 1 into. And all of this manipulation of I makes sure to pick a column that doesn't already contain a 1 at this location. Then we'll load the 1 into this location. I commented out a line to calculate the location in the matrix. It doesn't have to be here, but it's good to see that this function functions like it is here. So I hope that you have found this video to be helpful, insightful and interesting. Please click like and subscribe if you did. Please leave some helpful thoughts in the comments if you have any. Feel free to share this video, and thanks a lot for watching.